Very good morning, friends. I extend a hearty welcome to my YouTube channel. And in today's video, we are going to learn about drawing of the development of the lateral surface of an object like this. I'll tell you how to find out what the object is. When it is cut by two section planes, S1, S1 and S2, S2. So in the question, it reads like this: for the cone shown in figure, obtain the development of P. So even without mentioning this cone, you can understand this object, whatever you got here, is cut by two section planes. This phi indicates it is a circular dimension. So again at the end he has given, so it is nothing but this is the prustum of a cone which is cut by an inclined section plane and a horizontal section plane, both being perpendicular to VP, and hence they are seen as S1, S1, S2, S2, two lines in the front view. So friends, in most of the cases, you also have questions like this, wherein instead of giving the statement or the problem in statement form, it may also be given in the form of a figure. And this is even, it can be held or it can even be given for objects like pyramid, then cylinders, etc. So friends, this diameter from the figure, this indicates the diameter, this indicates the diameter separated by this gap. Now we want to draw the development of this part P as for the lateral surface. Friends, what do we do? Here, we know very well it is the development of a cone which is being cut by two section planes, and hence to draw the development of any cone we need two parameters, namely the radius of the base which we call as small r, and the length of the generator or the true length of the generator which is represented by capital R. Friends, here what we can do, you have this inverted frustum of a cone. I am going to construct or extend this line, axis line, and obtain O, the apex of the solid. This is how you obtain O, the apex of the solid. And this distance from O to that base is called R. R is the length of this land generator or end generator, and this is small r, the radius of the base. So from this, friends, we can find out what is theta, the subtended angle that is given by the formula small r by r into 360 degree, and here small r is given to be 60 by 2, that is 60 by 2 is r, that is equal to 30 mm, and this capital R has to be obtained after completing this triangle or the cone. So this can be obtained from the figure. So friends, theta is equal to, after substituting the value, say you are going to get 140 degrees. Say, because I have not calculated, you will have to use the calculator, get the actual value of this theta and then substitute. Friends, after getting the value of this subtended angle, let us see how to obtain the development of the part between these two section planes. Friends, we have R. So using that R, I can write a line, a vertical line, say, of length is equal to R, and this is the apex of the solid. And here, friends, we have to mark the angle, that is the subtended angle. Whatever the angle that is given or the calculated, you have to draw an arc through this, and this angle is theta, that is equal to 140 degree we have got. Say, is a value. Now friends, as you all know that the cone has no edges or corners, and hence what we do, we divide the base of this, that is the base having 60 millimeter dia, into some number of equal parts. Generally it will be minimum 8 or even more than that can be done. It's better to have this circle drawn and divided into 8 equal parts. How to obtain that 8 parts? You can write a vertical and horizontal line. You will get the circle base divided into 4 parts. Again, a line at 45 degree here, another line at 45 degree perpendicular to that will give you the circle divided into 8 equal parts. And we can name these as A, B, C, D, E, F, G and H. These are the points on the base. And let us transfer all these points onto the base. That is, A is here. We'll call this as A dash. This is E dash on the other end. This is in the center GC, G dash, C dash. Here you get B and H. So we are going to get here B comma H or B dash H dash. Here you are going to get D and F at the same distance. This is going to be D comma F, D dash comma F dash. So friends, we have divided this circle into 8 equal parts, and here we want to draw the development of this part. So since none of the generators OA to OH are totally removed by this section plane, we can start or commence the development from any one of these generators OA, OB, etc. Let me say I am starting with OA. So this is A, and the last end will also be A. This is R, which is also equal to true length obtained from this figure. This is true length, this is R. We have divided the circle into 8 equal parts. So the same way, you divide this segment into 8 equal parts. Now divide into 2. If you divide further, it becomes 4. Then again, if you divide them, it becomes 8. So 8 equal parts. So we can start marking, continue that. B, C, this is D, E, F, G, H and A. This is the base. A, B, C, D up to A is the base of that cone. Now friends, let us start with marking the development of section plane 1-1. Friends, you can see here, the section plane 1-1 is cutting all the generators from EE, passing through EE and cutting all the 8 generators. So let me join them here. So it is cutting here, G and C are cut here, it is cutting here and is passing through this. Friends, we will join all these points to the vertex or apex to say. And here friends, let me start with this point. This point. See, the generator O dash A dash is cut by section plane S1 S1 here. This is the true length because this OA is parallel to XY. So on this OA, take from A this measurement on OA. So I will take on OA the measurement. OA here, this again OA, the same measurement. That is this much on OA. Friends, coming to this, the generators OB and OH are cut here by the section plane 1, but this is not the true length. So I have to shift that to the true length line, either here or to that end. So take this measurement on OB and OH. OB and OH You are going to take that measurement. So we will say on OB and OH. Then it is passing through E. Where is E? E is here. It is passing through that point E. And friends, likewise, the one you have marked, and this has to come little low. So OA is correct. OA is marked. OE is marked here. Then you have got this point on OBOH. OBOH are not the true length. So I have to mark on OB and OH this distance is going to be somewhere here, lower than that. OB and OH. Then you have got this on OC and OG. They are also not true length. So you have to obtain those 2 points on OC and OG. So OC and OG will come somewhere here, little lower than that. This is higher, little lower. Then comes points on OD and OE. So shift that point to the end generator and get this point on OC and OG. OC, sorry, OD and OE. OD and OE. So you will get a point here and a point here. And then finally, you got a point there. So if you join all these points by a smooth continuous curve, this is how the points are obtained on the development for the portion of the pyramid cut by section plane 1 1. So friends, we have got so many points, let us not mark and get confused. We are getting so many points on this, and this is how section plane S1 is cutting this solid. Then when you move on to this second section plane S2, the section plane S2 is cutting the solid parallel to the base, and hence all these generators OA, OB, OC, everything are cut at the same distance. So what can be done now? You can take this vertex as the center, radius equal to this length on this last generator. You can draw an arc, the center O and radius equal to this much length, this distance. Friends, this is the way the section plane is cutting the second, that is the horizontal section plane. And friends, here we have joined already this vehicle passing through all this point. It should be a smooth continuous curve, and the portion between these two. So this figure will give you development of P, the portion that is the lateral surface of the portion between section plane 1 1 and section plane 2 2. Friends, I hope the presentation was useful to you, and in later on in some other video we are going to show the application of this concept when you are going to make the liter flask, that is the measuring can used in petrol pumps. Friends, I thank you very much for watching my video, and if you are happy with this presentation, please subscribe without fail and share the information with all your friends. Have a nice day.